Alright, pre-calc. So chapter 1, section 8 is all about inverse functions, which you guys have undoubtedly seen in Algebra 2 or FST if you've taken that class. So we're going to do two things. We're going to verify if two functions are inverses. There's a process we're going to do for that. It's going to have to do with, if you remember when we made composite functions in last section. And then we're going to learn how to find a function's inverse. First thing, if two functions are indeed a variable, so f of x and g of x, this is just the name of the two functions, f and g, if they are variables, or if they are inverses, then when we plug in, when we create our composite functions, they should simplify to x. So both must be true. So we're going to create composite functions, f of g of x and g of f of x, and simplify, and if they are indeed inverses, they'll simplify to just x, and that will say that we undid all of our inverse or all of our operations. So if we've got two examples here, I want to first test f of g of x. So that means I'm taking this whole thing, g of x, and I am plugging it in to x right here. So I'm going to say 3, and then in parentheses, x minus 2 over 3 plus 2. And I can start by distributing this 3. Well, if I do that, I get just x minus 2, because these 3's will cancel out, plus 2, and now you'll see the minus 2 and the plus 2 cancel out. And so, indeed, that first half is true. F of g of x does equal x. Now, we need to make sure it works both ways. So now, to do the other way, I'm just going to take this 3 of x, or f of x, and plug it in for that one. So now we're looking at g of f of x, where we plug in f into g, and we get that 3x plus 2 minus 2 in the numerator all over 3. And we can start to simplify here now. So our 2's will cancel out. We have 3x over 3, and now our 3's cancel out, and so we get g of f of x equal to just x. So these two, since they both simpled out to just x, these two are indeed inverses. Okay, now we can test out the one we have over here. So f of g of x, so that means I'm taking this whole term and I'm plugging it in right there. So I'm going to have 5, so that should be equals 5, and then in parentheses, x plus 5 over 9 minus 9. And if I distribute that 5, what doesn't cancel out as neatly as it did in that last problem, you'll see. And so we actually end up by distributing that into our numerator only. Remember, when we multiply here, distribute only the numerator. We're going to have 5x plus 25 over 9 minus 9. And even if we try to change this 9, even if we try to get common denominators here, so I could say that would be 81 over 9, which I did, so I'd have common denominators now. Well, 5x plus 25 minus 81 is going to give us 5x, and then minus some number here, and over 9. So this is not going to work. It does not equal x. So therefore, these are not inverses. Okay, and it could have actually happened sometimes that maybe your first one will become x. You still need to test your second one. It doesn't always necessarily mean it's going to equal out to simplify x as well. So there's one example where we did have two inverses, one example where we didn't have inverses. Okay, now to find a function's inverse, so suppose you weren't given both, you're only given one function. To find its inverse, what you first want to do is change the f of x to y, or if it's g of x or h of x, whatever the function's name is, you're going to change that to y. After you do that, you switch the x and y in the equation, and you solve for y. So we change f of x to y, swap the two letters, and there may be multiple places where x has to change to y, and then we solve for y, and finally we change that y to what we call the f inverse of x. This is called your inverse, f inverse of x. Okay, so a couple examples of that. If I just change, I'm going to do these pretty quick, y equals 7x minus 5, and now I'm going to swap positions, so x equals 7y minus 5. And I'm going to solve for y. So I'm going to add 5, and then I'm going to divide by 7. And remember, the whole thing needs to be divided by 7. So that means the f inverse of x equals x plus 5 over 7. And you can always check that by plugging the two into each other and seeing what we get. Okay, another example now, a little more complicated because we have a y squared. So I'm going to start the same way. I just switch the x and the y. And so I'm going to switch my x and my y. And now I'm going to solve. So I'm going to start by adding 1. And then I'm going to square root. So I have x plus 1 equals y, and then I get x plus 1 equals f inverse of x. Now you'll notice here that I didn't put the plus or minus in the front. And the reason I didn't do that has to do with our restriction right here. And the reason that restriction exists is because we have to restrict that in order to get an inverse. Okay, so we've talked about vertical line tests in order to create a function. There's something called a horizontal line test in order to have an inverse. So in this case, this only works when we use half of this function. So we've restricted our domain so that this function will actually have an inverse. And because we restricted that domain, we're only going to get positive results out, which means we don't need the plus or minus. We have just the square root of x plus 1. Okay, and finally the last one here, you'll notice no domain restriction. I'm going to do my same process. I'm going to change my f of x to y and then swap my two pieces. I'm going to start by adding 1 here. So I swap my x and y, I add 1. I'm going to divide by 4. And now, in order to simplify this, or to solve this for y, we need to take the cube root of both sides here. So we have the cube root of x plus 1 over 4, and that equals y, or I can just jump ahead a step here, and that equals my inverse of x. Okay, so there are 3 examples, one linear, one quadratic, and one cubic, of how to find an inverse of a function. Sometimes we have to reduce or restrict our domain so that we have what's called a one-to-one function, and we can only find an inverse of what is called a one-to-one function. We'll explore that a little bit more in class tomorrow. Okay, so that's it. That is your 2 things that we're looking at in 1.8. We're verifying functions, which means we have to take the composite of the functions both ways, f of g of x and g of f of x, and then we find an inverse function, those 4 steps. Basically, we're just swapping x and y, solving for x, and we're going to call that our inverse function. I'll see you next time, guys.